friends, how are you? I hope you are well. Success does not come to us. We have to go to success. Many of my students, they asked those know me through telephone, sir, you started the video but you did not introduce yourself. I would like to say that in science, practical comes before theory. Practical precedes the theory. So, I think this is only time to reveal myself. Myself, MANAS SENAPATI, basically from Odisha, but my teaching career is in South India, especially in Kerala and Telangana. Telangana in the sense Hyderabad and especially Warangal and Hanamkonda. 22 years or more than 22 years I have teaching experience in secondary schools handling both maths and physics, IIT and foundation classes. This is about me and about you. I think when you are giving comment, definitely you will mention. As a result, I can know about yourself also. Let us come to the topic. Today, in this topic, I am going to explain about the thermal properties of matter. You know that matter has different types of properties. One of the properties is the thermal property of matter or thermal properties of matter I have mentioned. Okay, this is one of the very important topics so far as class 11 is concerned. Okay, from the JEE point of view also it is one of the important topic. At the same time it is also easy topic. So it is better to start. So when I say about the thermal properties of matter, and I am saying that this is the introduction class of the topic, so it will be injustice if we don't discuss these two terms. One is the heat, another one is the temperature. Then what do you mean by heat and what do you mean by temperature comes to our mind. Lower classes also we have studied about the heat and temperature. So I can say that heat is a form of energy. Heat is a form of energy which is in transit, which can flow from a body of higher temperature to a body of lower temperature until reaching at the equilibrium. What about the temperature? Listen carefully. Children, suppose two bodies are there. One cold body, one hot body. You can take example of a cup of hot tea. If a cup of hot tea placed on a table, after some time you will find that the temperature of the tea decreased. At the same time, if you expose a glass of ice cold water on a table in a hot summer day, you will find that the temperature of cold ice water increased. What is the reason? The reason is that there is a transfer of energy. Transfer of energy from hot coffee to surrounding atmosphere because both maintain different temperature. The cold, ice cold water, its temperature raised. The thing is that heat supplied from this atmospheric air to the ice cold water. That means there is a transfer of energy. So in this topic, specially we study how to measure the temperature how the heat transfer from one body to another body and what are the different processes. Let us go details through these two terms, temperature and heat. So, suppose one metal chair, it is exposed in the sunlight. If you touch it, you will find it is hot. What is the reason? The reason is that heat from our body the heat from the hot chair transferred to our body. That means the heat what was present in our body, now it is increased. That is due to transfer of heat from the hot chair to our body. So we feel the chair is hot. At the same time, if I touch a ice cube, I shall feel the cool. The thing is that heat is transferring from my palm to the ice cube. That means there is a transfer of a heat. So I can say that heat is a form of energy which causes the sensation of a coldness or hotness when it comes in contact with us. Okay? Whether it is physical contact or without physical contact also we can feel the hotness. Okay? See here. So, the degree of hotness or coldness is called temperature. I can say that other way, the average translational kinetic energy of molecule of a substance. The average translational kinetic energy of a molecule of a substance. In a substance, number of molecules are there. They are in random motion. They have kinetic energy. Due to that kinetic energy, we get the heat energy. That kinetic energy converted into heat energy. So I can say that it is the average translational kinetic energy of a molecule of a substance. I have written the degree of hotness or coldness of a body is called the temperature. Other way, I can say that suppose two bodies. Here is one body is there A, here is another body is B. Okay, both bodies of different temperature. For example, 33 degrees Celsius, 20 degrees Celsius. Both bodies are in contact. So there is a transfer of heat from a body of higher temperature to a body of lower temperature. So I can say that temperature decides the direction of flow of heat. Due to temperature only I am able to say that heat flows from body A to body B, because here temperature more, here temperature is less. So I can say that temperature is a physical quantity which decides the direction of flow of heat. I can say it is a physical quantity which expressed in a specific scale. So let us discuss about the different scales. So I said that heat is a form of energy which flows from a body of higher temperature to a body of lower temperature until reaching at equilibrium or until reaching the net transfer of heat energy 0, it will continue to flow. So I can say in this way also, heat is the cause temperature is the effect. Heat is the cause, temperature is the effect. What is the SI unit of heat? The SI unit of heat is joule. We use the units calorie, kilocalorie, but in SI system the unit of work and energy both are joule. So most of the time we use joule. Now let us come to the temperature, which is the major part of the topic, thermal properties of matter. There are different scales are there to measure the temperature. Some of the important scales are Celsius scale, Fahrenheit scale, Kelvin scale. So I said the degree of hotness or coldness is the temperature. That means temperature is a relative term. Temperature is a relative term. If we want to measure the temperature, we need some special scale. I said that the major scales are Celsius scale, Fahrenheit scale and Kelvin scale. But to prepare these standard scales, there must be two reference points. One reference point we say lower fixed point, or I can say that this is the ice point. Another one is the upper fixed, or you can say higher fixed point. This is called the steam point, or in case we say it is boiling point. This ice point, we can say it is the freezing point. Ice point means the temperature at which pure water convert into ice at normal pressure, that is called the ice point or freezing point. So far as the steam point or boiling point is concerned, this is the temperature at which liquid convert into gaseous state without changing the temperature at normal atmospheric pressure. So that point is called the steam point or boiling point, what we have studied already in the lower classes, no doubt at all. Now since it is the introduction class, so I felt it is wise to discuss all these things what we studied in the lower classes. So children, now we will discuss how to change the temperature from one scale to another scale. Listen carefully. I said that to prepare one standard scale, we need two reference points. One is the lower fixed point, one is the upper fixed point. Now you see the three different scales. Suppose this is the ice point, or you can say freezing point. This line represents the steam point. Okay, this is the Celsius scale, this is the Fahrenheit scale, this is the Kelvin scale. So in Celsius scale, the melting point of ice, or you can say freezing point of water, is 0 degree centigrade. This is called the lower fixed point. And the boiling point of water, what is steam point, that is the upper fixed point. So this is 100, this is 0, this is 100. Okay. So we started from 0, this is 100. If it's the Fahrenheit scale, in the Fahrenheit scale, ice point starts from 32. The steam point is 212. And so far as the Kelvin scale is concerned, here the ice point or freezing point is 273.15. Here is 373.15. Generally we use 373 to 73. So in Celsius scale, lower fixed point or lowest fixed point is the ice point, or you can say freezing point, or you can say that is the melting point of ice, that is 0, and the upper fixed point is 100. And in Celsius scale, this gap or this difference is divided into 100 equal divisions. Each division is 1 degree Celsius. Similarly, in Fahrenheit scale, the gap between 32 and 212, which is 180. That means the lower fixed point and the upper fixed point gap is divided into 180 equal parts. It represents 1 degree Fahrenheit. And so far as the Kelvin scale is concerned, here the freezing point is 273.15 Kelvin and the steam point is 373.15 Kelvin. This gap is divided into exactly 100 equal parts, which is also equal to the degree in Celsius scale. So here it is divided into 100 equal parts. It is 180 parts. It is divided into 100 equal parts. So far as the Celsius and Fahrenheit scale is concerned, here the lower and upper point, or lower fixed point and upper point fixed point, depends upon the nature of the liquid. It depends upon the thermal expansion of the liquid. But so far as Kelvin scale is concerned, it does not depend upon the thermal expansion of the liquid. It is independent of the thermal expansion of the liquid. So Celsius scale, Fahrenheit scale, it depends upon the thermal properties of the liquid, whereas the Kelvin scale does not depend upon the thermal properties of the liquid. Okay, so here I said that the temperature is the average kinetic energy of the molecule of a substance. In Kelvin scale, we say the temperature is, we say Kelvin scale or we say absolute scale. The temperature we say absolute zero temperature. What does it mean? It means in a substance, when the molecules seize its kinetic energy, when the vibration of the molecule, suppose if the movement of the molecule stops, there will be no kinetic energy, there will be no temperature. That temperature is called absolute temperature. That temperature is called absolute temperature. So let us discuss how to interchange between Celsius, Fahrenheit and absolute temperature. So let us start from the graph. Suppose this graph I am drawing the Fahrenheit versus Celsius. This is the 0. This is the Fahrenheit scale. Starts from 32. Suppose the graph came like this way. This is the 0. This one is the 2, 12. So this is 100. Listen carefully. So from the graph, we can establish the relationship between the Celsius scale and Fahrenheit scale. See that. C minus 0. C means the temperature in Celsius scale. Or I can say that here I have written that 100 minus 0 divided by what I have mentioned here. I have mentioned that temperature in Celsius scale minus lower fixed point upon temperature in highest temperature in Celsius scale minus lower fixed point upon highest temperature in Fahrenheit scale, or you can say upper fixed point minus lower fixed point. So from this graph we can find the relationship between Celsius scale and Fahrenheit scale. Listen carefully. So in Celsius scale I can write C minus 0 by 100 is equal to F minus 32 by 180. Listen carefully. I have written the temperature in Celsius scale minus lower fixed point, and here I have written the number of divisions between upper fixed point and lower fixed point. In case of a Fahrenheit scale also I have done the same thing. Listen carefully. So I can write like this way. C minus 0 by 100 is equal to F minus 32 by 180. Similarly, I can write K minus 273 is equal to 100. I can write in S minus lower fixed point divided by upper fixed point minus lower fixed point is equal to S minus lower fixed point divided by upper fixed point minus lower fixed point. This is also S minus, okay, so it is better S minus lower fixed point by upper fixed point minus lower fixed point. Everything, that means I want to say that the common formula is reading in the scale minus lower fixed point divided by difference between upper fixed point and lower fixed point. So this is the relation through which we can exchange temperature from one scale to another scale. Let us discuss with one example how to change the temperature from one scale to another scale. Listen carefully. Suppose I want to change the temperature from Celsius scale to Kelvin scale. So I can write C by 100 is equal to K minus 273 divided by 100. Okay. So 100 cancel. So I can write that K is equal to C plus 273. Most of the books we use suppose the temperature in Kelvin scale T. So I can write T is equal to C plus 273. So this is the way I converted Celsius scale to Kelvin scale. So let us understand this concept in better way with the help of an example. For example, convert 75 degrees Celsius into Fahrenheit and Celsius. We know that temperature in Kelvin scale is equal to C plus 273. So here Celsius 75 plus 273 is equal to 348. Clear? This is the temperature in Kelvin scale. Next, we have to change this temperature into Fahrenheit scale. We know that F minus 32 upon 180 is equal to C upon 100. Implies that F minus 32 upon 180 is equal to 75 upon 100. Implies that this 0 cancel, 2 5 10, 2 9 18, 5 15. Implies that F minus 32 is equal to 15 into 9 is equal to 135. Implies that F is equal to 135 plus 32 is equal to 167 degree Fahrenheit. Got the answer? Let us go to one more problem. In iron scale, the ice point is 0 degree and steam point is 50 degree. Convert 20 degrees Celsius into ions scale. Here, in place of Celsius scale or the Fahrenheit scale, I have mentioned one more new scale. Does not matter. I have written ion scale. We need lower fixed point, upper fixed point. That's all. We can convert temperature of any scale into any other scale. Let us see how we are doing. So here lower fixed point in that scale is 0, upper fixed point is 50. We have to convert this 20 degrees Celsius into that scale, ion scale. We know that in Celsius scale, 20 upon 100 I have written. This is the C minus 0 upon number of divisions, means upper fixed point minus lower fixed point. What about in the ion scale? Upper fixed point how much? Upper fixed point is given 50. So lower fixed point, okay, I committed mistakes. So we have to get the temperature in ion scale. We have to find it. So here 0 is the lower fixed point, upper fixed point is the 50. That means 50 minus 0. I can write this is A upon 50. 50, this is 2, this is 10. Implies that A is equal to 10. Finished. Got? So any scale does not matter. We should know the lower fixed point and the upper fixed point. Let us see one more problem. In a faulty thermometer, upper fixed point is 104 degrees Celsius and lower fixed point is minus 4 degrees Celsius. If the temperature is 32 degrees Celsius, then correct it. How to correct? Actually, it is a wrong thermometer where the lower fixed point is minus 4 degrees Celsius. Upper fixed point is 104 degrees Celsius. And the temperature what we recorded, that is 32 degrees Celsius. We have to correct it. At first we will write the formula. Is minus lower fixed point upon upper fixed point minus lower fixed point. This is for the faulty scale. Similarly, lower fixed point upon upper fixed point minus lower fixed point. This is for correct scale. See here children. So this is reading. This is lower fixed point. This is the difference between upper fixed point and lower fixed point. I have mentioned here faulty scale. So faulty scale, right? Reading how much? 32 minus lower fixed point, that is minus 4. Upper fixed point, sorry, 104 minus 4 is equal to, this is the faulty scale, this is the correct scale. Correct scale means Celsius scale. Lower fixed point is 0. Upper fixed point, lower fixed point, that is 100 minus 0, or I can write S upon 100, implies that 32 plus 4 upon 1. Okay, it is better I should write offside. It may not appear for you. Plus 4 upon 104 plus 4 is equal to S upon 100, implies that 36 upon 108 equal to S upon 100. So 1, 3 implies that S upon 100 is equal to 1 upon 3, implies that 3S is equal to 100. That implies that S equal to 100 upon 3, that is equal to 33.33 degree Celsius. That means the temperature what we found 32 degrees Celsius in the faulty scale, after correction it became 33.33 degree Celsius. That means if we are using the wrong scale, if we know its lower fixed point and the upper fixed point, then easily we can correct it, that is no doubt. So children, one more small problem we see before completing this video. What is the temperature which is equal both in Celsius and Fahrenheit scale? Which temperature equal both in Celsius and Fahrenheit scale? Let it be X. At first we will write the relation between Celsius and Fahrenheit scale. We know that C upon 100 is equal to, or I can write it, F minus 32 upon 180 is equal to C upon 100, implies that X minus 32 upon 180 equal to X upon 100. Clear? Here C and F both I have taken X. So in place of C I have mentioned X. In place of F also I have taken X. Clear? cancel, 2 5 10 to 9 implies that 5x minus 160 is equal to 9x implies that 9x implies that 9x minus 5x equal to minus 160 implies that minus 4x equal to minus 160 implies that x equal to minus 160 upon 4, it is equal to minus 40. That means minus 40 is the temperature which is equal both in Celsius as well as in Fahrenheit scale. So this is for today's video. So in the next video definitely we'll go through the entire topic, no doubt at all, but step by step. So for this, I think for this video this is enough. Thank you.